Okay, on this first problem on your college algebra review on number 1, it says we have this equation x squared over 16 plus y squared over 9 all equals 1. The directions say it wants us to graph the ellipse and locate the foci. So to go ahead and graph this, first thing we need to do is go ahead and find the center. Well, the center is at 0, 0 since there is no shifts happening in the x squared or the y squared direction. Now to go ahead and graph this number underneath the x, just take the square root of it. Square root of 16 is going to be 4. That's going to be your horizontal radius, so that's going to be the radius in the x direction. Now this number under y, take the square root of 9, which is 3. That's going to be your vertical radius, or in other words, that is the radius in the y direction. So to graph this, I go to my point 0, 0. And then in my x direction, my horizontal direction, I'm going to move a total of 4. So I move it out 4, put it out there. And to the right 4, to the left 4. Now I'm going to move in the y direction a total of 3. So I go up 3 and down 3. And then I go ahead and draw in my ellipse. Once I'm done doing that, I just need to remember my formula for my foci, which is profocus. So that formula is a squared minus b squared equals c squared. So a, remember, is your radius along the major axis, and b is going to be the radius along the minor axis. So the major axis is the longer one, so that's going to be the one that's horizontal, in other words, in the one in the x direction. This one is 9, so that's going to be my minor in the minor direction. So now setting this up, you can go ahead and just plug that into your formula right here. So you can either put in your 4, and you can put in your 3, but since they're already being squared, you can actually substitute in the 16, and you can substitute in your 9. So 16 minus 9 is going to be 7. And then you take the square root of both sides, and you get c is going to be plus or minus the square root of 7. And remember, c is the distance from the center to its focus. So remember, your focus is always on your major axis. So since it's always on the major axis, our major axis is the x. So when I actually go to list this as an ordered pair, I list that as plus minus the square root of 7 and 0. And that is graphing and finding the foci of number 1. Now number 2, we've got 4x squared plus 9y squared equals 36. This is also the equation of ellipse. To put it into standard form, I'm going to divide everything by 36. So I divide all of my terms by 36 to get it into standard form. And I'm just going to go ahead and do it exactly like I did number 1. So 436 is going to reduce down to x squared over 9. So 9y squared over 36 reduced down to y squared over 4. And this all equals 1. Now that I've done that, put it into standard form, I can go ahead and graph it just like I did number 1. So again, there's no shift happening here. So I have my center at 0, 0. My foci formula is a squared minus b squared equals c squared. So to go ahead and find my foci, just take this 9, substitute it in, the 4, substitute it in. 9 minus 4 is 5 equals c squared, so c is going to equal plus minus the square root of 5. Graphing this, I go to my center, which is 0, 0. So the square root of 9, which is 3. So in the x direction, I'm going to move left 3 and right 3. And in the y direction, your vertical direction, I'm going to move a total of 2, so up 2 and down 2. And that's what my ellipse is going to look like. Now to go ahead and list my foci in the correct place. Plus minus 5, square root of 0. Or sorry, square root of 5 and 0, because the x is your major axis or your longer axis. So that'd be graphing and finding the foci of number 2. On number 3, now we're going to go backwards with it. It says on number 3, it says my foci is negative 2 and 0, 2 and 0. And my vertices are negative 4 and 0 and 4 and 0. So remember your vertices, that's plural vertex. So that means that right here and right here are going to be where my vertices are at, my vertex. And so those are the major vertices. So we know that this right here, this ellipse, would look like something like this. I don't know how far it moves on the y, not yet until I actually figure it out. But I know that my general formula says that x squared over a squared plus y squared over b squared all equals 1. So a is going to be this radius. So this radius right here is a total of 4. So I'm going to go ahead and substitute that in as 4 squared. Now to find the radius of my minor axis, I'm going to have to use my foci formula. So using my foci formula, I've got a squared minus b squared equals c squared. So I know here is my a, so that's going to be 16. B is what I'm looking for, and C is going to be that distance from the center to the focus. So again, if we scroll up here, so again, our focus was at negative 2 and 0, 2 and 0. So I'm just going to substitute those numbers in. So back to my foci formula, substituting in that 2. So I end up with 16 minus b squared all equals 2 squared. So 2 squared equals 4. So I'm going to move this 4 over here, and I'm going to move the b squared over here. So 16 minus 4 all equals b squared. So simplifying that down, 16 minus 4 is going to give me that 12. And so 12 is equal to b squared. I don't bother taking the square root because it's just going to be substituted in to that equation. So the formula that comes from the equation that has foci at negative 2 and 0, 2 and 0, and vertices at negative 4 and 0, 4 and 0, ends up being x squared all over 16 plus y squared all over 12 all equals 1. On number 4, now we're going to go ahead and take a look at an ellipse that has a shift to it. So on number 4, here's my equation that says I've got x squared, or x plus 1 squared all over 16 plus y minus 2 squared all over 4 all equals 1. I want to graph the ellipse. I'm going to add also on there and give the location of the foci. So to graph this ellipse, first we've got to find our center. So if you look at the general form of an ellipse, it's x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And your center is that h and k. In other words, it's those answers to x minus h and y minus k. So here I have x plus 1. I find that answer, and that answer is going to be negative 1. I got y minus 2. I find that answer, and that is going to be a positive 2. There's your center right there, located at negative 1 and 2. So to graph this, I go to the point negative 1 and 2, put my dot there. So here's a negative 1, positive 2. Okay, now that I've done that, I look at this first equation right here. The square root of 16 gives me 4. So that means I'm just going to keep it in line. So I'm just going to move over 1, 2, 3, and 4, and move to the right 1, 2, 3, and 4. So there'd be the location of my two vertices, my major vertices. And now if I take the square root of 4, I'm going to get 2. So keeping this in line, I'm going to move up 2 and down 2. Now I can go ahead and draw in my ellipse, and that's what it looked like. So now I got to go ahead and find the foci. So to find the foci, I use my formula. My formula says that a squared minus b squared equals c squared. So again, here is my a squared, which would be 16. Here's my b squared, which is 4. I go ahead and substitute those into that equation. So here's 16 minus 4, all equals c squared. So I put it in as 16 and 4 because that's already the radius squared. So 16 minus 4 is going to be 12 equals c squared. So c is going to equal plus minus the square root of 12. And I know that the square root of 12 can be simplified down because that's the square root of 4 times the square root of 3, and that's going to give me 2 square root of 3. So there is my c value, plus minus 2 square root of 3. Now I need to remember that the foci will shift just like all the rest of my graph shifts. So I locate my major axis to decide which the focus is sitting on. So here's the longer axis, so that means that it's going to be in place of this. It's going to be with my shift at negative 1. And then the 2 is just going to stay the same. So as I go to write this as an ordered pair, I'm going to rewrite it as negative 1 plus or minus 2 square root of 3 and 2. And that would be the location of my foci. So make sure you use the center to show the shift in the foci. Our next problem on number 5. Now we're going to be changing it up a little bit. So you can notice we've got x squared over 49 minus y squared over 100 equals 1. So it says find the vertices and locate the foci for the hyperbola whose equation is given, and I also added and graph it. So whichever variable comes first, that's the direction that the hyperbola is going to be opening in. So in this case right here, so the x variable comes first. So that means the hyperbola is going to be opening horizontally. In other words, it's going to be opening in the x direction. So it basically follows the exact same rules as your ellipse. So notice the center. There's no shift happening here, so that's why it's at 0, 0. So I come here to 0, 0. And then I'm going to go ahead and move in this x direction, square root of 49, which is 7. So I'm going to move to the left 7 and also to the right 7. Those right there are your vertices. So if you want to go ahead and just list them right now, which I did, just go ahead and list those as plus, minus 7 and 0. Now from those vertices, I'm going to move 10 to go ahead and draw in my asymptotes. So I'm going to move up 10, and then move down 10, and up 10, and down 10. You'll notice those form those guidelines, those asymptotes that we're going to use to draw our shape with. And so after you're done putting in your asymptotes, now go ahead and just draw in your hyperbola. And that's what it'll look like. Now that you've drawn your hyperbola, we can go ahead and find the foci. So your foci formula is a squared plus b squared all equals c squared. So again, it just matches the exact same thing that you did previously with your ellipses. So let's scroll up here and take a look and see what our a squared and b squared are going to be. So here is our a squared and b squared. It doesn't really matter which one you put in which, because basically 2 plus 3 is the same thing as 3 plus 2. So substituting those in, I've got 100 plus 49 all equals c squared. So 149 equals c squared. So plus minus square root of 149 is c. Now as you're listed as an ordered pair, it's going to be sitting on that transversal axis. So it's going to be sitting on that x-axis. So that's plus minus the square root of 149 and 0 as you're listed as an ordered pair. Now to write your equation of your asymptotes, you got y equals plus minus the slope times x. So remember the slope is how far you rise compared to how far you run. So if I look right here, there's two ways to actually see that. You can actually go ahead and count it out. I mean, you can see that I went up 10 and then over 7. And so that'd be that point right there. So you went up 10 and over 7. Or you can actually just look, okay, here's underneath the y. That tells me how far I rose. That's going to be 10. Here's my x. That's going to tell me how far I ran. So that's square root of 49, which is 7. Once you have those numbers down, just go ahead and substitute them in. So you got your asymptotes at y equals plus minus 10/7 x. And notice you don't have to worry about that plus b because that y-intercept is just 0. So that's why you just end up with y equals plus minus 10/7 x. And notice it's plus minus because you've got one asymptote going up and the other asymptote is going down. Okay, on number 6, it says we've got x squared all over 4 minus y squared all over 16 all equals 1. It says find the location of the center, vertices, and foci for the hyperbola described by the equation and the graph. So again, the centers are right here, which is going to be at 0, 0. So none of those are being shifted or moved. So here's my vertice. So the square root of 4 is going to be 2. And then my minor vertice would be the square root of 16, which is equal to 4. So to graph this, I go to the center, which is 0, 0. So this is going to open in the x direction because x comes first. So I'm going to move 2 along my x-axis or horizontally. And then from there, I'm going to move a total of 4 to form my asymptotes. I'm going to go up 4 and down 4, forming these asymptotes. Now that I've done that, you can draw in your asymptotes. and then go ahead and draw in your hyperbola. So that's what your hyperbola is going to look like. Now I just need to go ahead and find the foci. So my foci formula is a squared plus b squared equals c squared. So again, just substituting in your numbers. And since there's a plus sign there, it doesn't really matter which one you put in which one. So you got 16 plus 4 is 20 equals c squared. So c is going to equal plus minus the square root of 20. And go ahead and simplify that down because the square root of 20 is equal to the square root of 5 times the square root of 4. And the square root of 4 is going to be 2 square root of 5. So there's your c value, plus minus 2 square root of 5. Now since x came first, we write that as an ordered pair of plus minus 2 square root of 5 and 0. Now the equation of your asymptotes is y all equals plus minus m times x. So here's my formula. And remember, you don't have to worry about that plus b because that plus b is just 0 because it goes through the origin. So now we just need to see how far. So remember, the m is our slope. So we just need to put rise over run. So you can actually even count it out if you want to, or you can just actually look underneath your values right here. Because notice that to get to my asymptotes, I went up 4, and then I went over 2. So that would be your slope. Or you can just look at this right here. Here's the number underneath y, so that's 4. Here's the number underneath x, that's 2. So I went up 4 and over 2. So I substitute in those values for my slope. So I'm going to substitute them in. I got y equals plus minus 4 halves x. That simplifies down to y equals plus minus 2x. So that's your graph, your foci, and your asymptote and your centers for number 6. On number 7, we're going to go backwards with it. So on number 7, they give us the foci, they give us the vertices. So your foci is on negative 7, 0, 7, 0. Your vertices are at negative 6 and 0, 6 and 0. Whenever I do going backwards with mine, I like to just make a sketch of it so I can figure out exactly what direction it's opening in. So my vertices are negative 6 and 0, so I come back here negative 6 and 0, and I go to 6 and 0. My foci is here at negative 7 and 0 and 7 and 0. So that means my parabola, or sorry, my hyperbola can only open in one direction, because the foci is always on the inside of my hyperbolas. So I know that once I've done that, halfway between that is 0, 0. So I know that's my center, which is at 0, 0. Now that I've sketched it, I'm ready to go ahead and write the equation. So notice that the general formula is x squared over a squared minus y squared over b squared. And remember, it opens horizontally, so that means the x variable comes first, because that is your horizontal direction. So now we just have to figure out what goes underneath my x squared and what goes underneath my y squared. So I figured out what goes underneath the x squared. I just have to look at my vertice. And since I moved a total of 6 right here, that means that 6 is going to be that number that goes in place of a squared. So substituting my 6, right here I've written a equals 6. And when I square that, that gives me 36. So x squared all over 36 is my first part of my equation. Now to figure out what my b squared is, I'm going to have to use my foci formula. So a squared plus b squared all equals c squared. So we know that the c is 7, and my a squared is 36, or in other words, that is 6 squared. So solving that out, put it over here, I got 36 plus b squared equals 49. I subtract those two, I get 49 minus 36 is going to equal 13. So there's my b squared, which is equal to 13. I go ahead and put that into my equation. And there's my equation that has those vertices and that foci. And that equation is x squared over 36 minus y squared all over 1. Or sorry, minus y squared all over 13, all equals 1. So that answer is A. Okay, number 8. It says find the location of the center, vertices, and foci for the hyperbola described by the equation and graph. So notice this time, now we're going to shift our equation. So here's the shift happening here. So I got x plus 4 So that's going to shift to negative 4. I've got y minus 2. So that's going to shift to 2. So that's the location of my center. So the location of my center is at negative 4 and 2. So I go to negative 4 and 2. I'll put my dot there. Okay, now that I've got my dot at negative 4 and 2, so notice in the x direction, I'm going to move 7. So moving in each direction 7. So moving to the left 7. Here's this vertex, and also to the right 7. So I've got 1, 2, 3, 4, 5, 6, 7. And notice those are my vertices. So in other words, here I was at negative 4 and 2. I'm moving in each direction, or in the y direction of positive 7, and in negative 7, so negative 4 minus 7 is negative 11 and 2, and negative 4 plus 7 is 3 and 2. So that would be the location of my vertice. Now to actually finish graphing it after I move those directions, now I'm going to move a total of 10. So I'm going to move up 10, and down 10, and up 10, and down 10, and then I have my asymptotes that I draw in. And then once I've got my asymptotes drawn in, I can go ahead and draw in my hyperbola. And so that's what the graph of that will look like. So now to find your foci, so substituting those numbers, so here's my A, 100, here's my B squared, which is 49. I add those together. Here's my formula. A squared plus B squared equals C squared. So I take 100 plus 49 equals C squared. This is 149 equals C squared. So plus minus the square root of 149 all equals C. And remember, this also shifts. So notice that since the x comes first, that's the one that is happening to the shift. So here's my shift right here, negative 4. So I got negative 4 plus or minus the square root of 149 and 2. And so that's going to be your center, and also your vertices and foci for the hyperbola of the graph of x plus 4 squared all over 49 minus y minus 2 squared all over 100 all equals 1. Now we just have to go ahead and list the asymptotes down. So remember the asymptote equation. So here's your slope. So if you remember right, we went up 10 and over 7. So that's y equals plus or minus 10 sevenths x. Now you want to go ahead and put in your shift. So notice that shift, you can take a look at it from both ways. The shift is actually written right here. And it's also over here with your center. So either way that you want to look at it, you just go ahead and write it in. I usually use this one right here because that is the equation of it. So remember, everything shifts, your asymptotes and your foci. And so that asymptote equation would be y minus 2 equals plus minus 10 sevenths times x plus 4. Okay, on problem number 9, we've got this parabola that says we've got x squared all equals 24y. It says find the focus and direction of the parabola with the given equation, and I also added and graph. So first off, I wrote down all of the different rows that we learned about our parabolas. So remember, an x squared parabola is going to open up, and that's going to equal 4py. X squared all equals negative 4py, opens downward. So your y squared parabola opens to the right. And then, of course, your y squared equals that negative is going to open to the left. And then remember that distance p, so the distance from the focus to the vertex, and from the vertex to the directrix, that's going to be that number p. So whenever you see the equation of a parabola, the first thing you want to do is you want to decide if it's going to open up, down, left, or right. Since we have an x squared equals 24y, an x squared parabola, that's going to be opening upwards, so it matches this one right here. So x squared equals 24y. So my vertex is going to be 0, 0. So I go to my vertex, put my dot there. And now I'm going to go ahead and find my value for p. So here I've got it's opening up, and 4p is going to equal this number right here, which is 24. So that means the distance of p is going to be 6. So from my vertex, I'm going to move up 6, and that is the location of my focus. And then down 6 is going to be the location of my directrix. So now that I've done that, I can go ahead and write down those two locations. So you can notice that your lattice line is going to be a total of 24. So since your lattice line is a total of 24, that means that I'm going to move 12 in each direction. So from my focus, I'm going to move 12 to reach the edge of my parabola. So now that I've done that, I can go ahead and draw my parabola. And now I can also go ahead and write down the location of my foci and my directrix. So notice your foci right here, that's located at 0, 6. And then that line, your directrix, is going to be y equals -6. And that would be the location of your focus at 0, 6, directrix y equals -6, and also that would be the equation of your parabola. Okay, on number 10, it says our focus is at 25 and 0. We've got our directrix at x equals -25. And the directions say find the standard form of the equation of the parabola using the information that's given. So the first thing you want to do is just want to kind of draw it out. And when you draw this out, so notice here's my focus. I put it here at 25 and 0. Here's my directrix, which is at x equals -25. And I know that my vertex is always halfway between those, so that's why I know my vertex is going to be at 0, 0. And because you know that your focus is always on the inside of your parabola, and the directrix is always on the outside of your parabola, that's why it's going to be opening to the right. Now that you know that, you can go back to problem number 9 and see that it matches up with your y squared equals 4px equation. So remember, you're going to have to memorize those shapes from number 9 to figure out which equation is being used here. So I wrote down my equation right here. So my equation is y squared all equals 4px. Now that I know that, I just have to put in my number p. Well, remember, p is the distance from the vertex to the focus. It's also the distance from the vertex to its directrix. So that means that my p is going to equal 25. I substitute it in my equation. I get 4 times 25, and 4 times 25 is 100. My equation is going to be y squared equals 100x. So that answer is going to be D. Okay, on this next problem, on number 11, it gives us the equation. It says we've got the equation y squared equals -4x. And the directrix on number 11 says find the focus and the directrix of the parabola with the given equation. And I also put and graph. So again, refer to number 9 to find the matching graph. So you'll notice that this is a y squared graph. So that means it's going to either open left or right. It's negative, so that means it's opening to the left. So I find my vertex. Notice there's no shifts that are happening here. So my vertex is at 0, 0. And it opens left. So I've got to find that number p, how far that's going to move in that direction. So here's my 4p. And remember that 4p equals this number right here, which is -4. So p is going to equal -1. So the distance from my vertex to my focus is going to be -1. So I move over here to -1, put in my focus. And remember that the directrix is also in the opposite direction, so that's going to be back 1. So now that I've graphed this, just have to go ahead and write those equations down. So writing those equations down for my focus, you can either look at it. So here's my focus. I've got it at -1 and 0. And then my directrix is 1 behind that, so that's going to be x equals 1. And now to make my graph, my parabola, so it is accurate, I check what the length of the lattice line is. And so the length of the lattice line is going to be a total of 4. So since it's a total of 4, half of 4 is 2. So from my focus in each direction to go graph this, I go up 2, down 2, keeping it all in line. And that's what my parabola is going to look like. So that's the answer, number 11. You have your graph that opens to the left. Your vertex is 0, 0. Your focus at 1, 0. Your directrix is x equals 1. And then your lattice line is going to be 2 in each direction for a total of 4. Number 12, now we're looking at parabolas that are shifting. So number 12, my equation is y minus 1 squared all equals 8 times x minus 2. First thing I do is I locate my vertex. So here's my x shift. My x shift is a total of 2. And then my y shift is going to be a total of 1. Now I know where the vertex is at, so I go over here to 2 and 1, put my dot here. When I write it down to its basic shape, you're going to notice its basic shape is y squared equals 8x. So now I can go to number 9, those rules on number 9, and discover y squared equals 8x would be a parabola that opens to the right. So now to find my focus, I take this 4p, and remember this is a y squared all equals 8x. So here's my value that I substitute in. That gives me 4p equals 8. I divide both sides by 4 and I get p equals 2. So keeping everything in line, from here to here I'm going to move a total of 2. And then also, my directrix is going to be back to, so you really can't see that dotted line because it is going to be covered up by the axis. That means that my focus, and if you just want to look at your graph, you can tell exactly that I went to 4 and 1. So that'd be one way of doing it. Or notice that since I moved 2, I can actually take my vertex, add 2 to it, and that gives me the same location of 4 and 1. My lattice line, this number right here, it gives me a total of 8. So when I divide that in half, that means in each direction I'm going to be moving 4. So notice my lattice line is this imaginary line right here. But you'll notice that I moved up 4 for this point, down 4, and that would give me my shape of my parabola. Now my directrix is that line back here. I went back 2. So going back 2 would just be this axis right here. And this axis right here is the axis of x equals 0. So there's my answer. My focus is at 4, 1. My directrix is at x equals 0. My vertex is at 2 and 1. And here's what my parabola looks like. That would be the answer to number 12. On number 13, got another equation that says we've got x plus 1 squared all equals 20 times y plus 4. The directions on this is the same as number 12. It says find the vertex, the focus, and the directrix of the parabola with the given equation. And I went ahead and told you to go ahead and graph it also. So on this problem right here, I first find my vertex. So the answer to x plus 1 is -1. My answer to y plus 4 is going to be -4. That's going to be my vertex. So I go over here to -1 and down 4. So that point, and -1 and 4 is your vertex. Now I have to decide whether it opens up, down, left, or right. So the basic equation is going to be an x squared all equals 20y. And that's just rewriting your equation without your shift. Kind of helps you to match it up on that problem from number 9. So from problem number 9, you'll notice that it's going to open up. And so we just now need to go ahead and find the value of p. So I know that 4p is going to equal this number right here. So 4p equals 20. Solve that and I get p equals 5. So for my vertex, which is at -1, -4, I'm going to move up 5 to my focus, and then down 5 to my directrix. And once I've done that, I can go ahead and write down their location. So their location, so notice there's two ways to it. You can take -4 plus 5, and that's going to give you that +1 right here. So this comes to be -1 and +1. So that's going to be the location of your focus. So now that I've got my focus, I can find my directrix. So my directrix is this line right here. So I went down 4 from 5, so my directrix is going to be at y equals -9. Now your lattice line is a total of 20, move in each direction 10. So that's what I did for my focus. I moved 10 in each direction, and that made it so I could draw my parabola accurately. So that's going to be the answer to number 13. Okay, on this last problem on number 14, the equation says we got 4x squared plus 16y squared minus 24x minus 64y plus 36 all equals 0. You're going to notice this is in general form. We're going to put it in standard form. So remember, the rules are to change it to standard form. You're going to put the x variables, y variables next to each other, and the constant on the other side. So that's the first thing I did. I put 4x squared minus 24x, 16y squared minus 64y, all equals -36. I'm going to factor out my constant. So So I factor out this 4. And when I do that, I'm left with x squared minus 6x. I'm going to factor out this 16. And when I do that, I'm left with this y squared minus 4y. And then I move this constant to the other side, which is going to be negative 36. Now I need to complete the square. So completing the square, remember you take half of b and square it. So here's my b. I take half of b, so that's negative 3. Negative 3 squared is going to give me that 9. I take half of negative 4, which is negative 2. Negative 2 squared is going to be positive 4. And don't forget to add it to both sides. I've got negative 36 plus 64, because remember, I actually didn't just add 9, I actually added 9 times 4. And I didn't just add my 4, I actually added 16 times 4 when I distributed on through. And so that would be the 64. Now that I've done that, go ahead and factor the x squared minus 6x plus 9. That's going to factor down to x minus 3 times x minus 3, in other words, x minus 3 squared. Y squared minus 4y plus 4 factors down to y minus 2 squared. And then I take negative 36 plus 64, and that gives me my 64. Last step, go ahead and divide everything by 64. And when you divide by everything by 64 and simplify it down, so this becomes a 1. And when I divide this out, that's 16 over 64 and 4 over 64. Simplify that down, so 4/64 is going to become 1/16. And then your 16 over 64 is going to become your 1/4, and that all equals 1. And so that matches D. So in standard form, I've got x minus 3 squared over 16 plus y minus 2 squared over 4 all equals 1.